Hey guys, so today we're going to be dealing with the product rule. The product rule is one of those rules that comes off more complicated since it's usually taught right after the power rule, which is relatively simple. And because you're going from something really easy to something a bit more complicated, students usually get confused when they come across the product rule. So we're going to leave this video being experts at the product rule. I'm going to do some examples. I'm going to break it down for you guys. So let's get into it. So what is the product rule? Well, the product rule is an important rule for taking the derivative when we have a product of two or more functions. So what do I mean by that? Well, say I have h of x is equal to f of x times g of x. So I got these two functions, f of x and g of x being multiplied together. So if I wanted to find h prime of x, so the derivative, well, I'd have to use the product rule in order to do so. So if I had also, t of x being multiplied to this whole bunch, I don't know why I put that bracket. Well, I'd still have to use the product rule because I have a product of two or more functions. So in order to find its derivative, we'd have to use the product rule. Now, it's very intuitive to think that the product rule, the derivative in this case, is equal to the derivative of each function all multiplied together. Well, this is wrong. It's a very normal guess. I think Leibniz himself also thought this initially until he discovered the actual product rule. So it's very normal to, guess this right off the bat, that the derivative in this case, or any case, when you have a product of functions, is the derivative of each of them and then all multiplied together. Well, this is wrong. So let's see what the actual product rule is. So as we said, the product rule, we use it when we have a product of two or more functions. So, well, what is the actual product rule? So if I wanted to take the derivative of, let's say, f of x times g of x, just like we had on the last slide, well, the product rule says, take the derivative of one of the functions. So in this case, we're going to take the derivative of f of x. We could have done g of x first, but we're going to do f of x first. We're just going to read left to right. It's usually easier to do that when you're starting out. And I don't know, it just makes more sense since we read left to right. So we're going to take the derivative of f of x first. Now, keep this in mind that f of x and g of x, these are just arbitrary functions. We could have had t of x and s of x, or w of x and a of x. It doesn't matter. We just chose f and g arbitrarily. So, okay, going back to this. So first we took the derivative of f of x. Then we multiply this by g of x. Not the derivative of g of x, just g of x. Then plus. Now we write f of x. So f of x, not the derivative of f of x, just f of x, times, I'll put this in brackets so it's easier to see, the derivative of g of x. There we go. That's our product rule. So what you're seeing here is that each one of the functions gets us a unique turn to get its derivative taken. And it's placed in its unique term. So you take the derivative of one of the functions and multiply it by the remaining functions. And that's one term in the product rule. Then you add, now take the derivative of a different function and multiply it by the remaining functions. And you keep doing that until you've done that for all the functions. So like I said, the product rule helps us when we have two or more functions. So say I had something like f of x times g of x times h of x. Well, what would the derivative be then? Well, we're going to do an extension to what we had up there. Like I said, each function must have its derivative taken, and it will get its turn in its unique term. So we're going to start with f of x again. So we're going to have f of x. Actually, I'm going to change this up. I'm going to use the prime notation, so I'm just going to write f prime of x. Same thing, right? So f prime of x times just g of x and h of x. We did not take their derivatives because it was f of x's turn to have its derivative taken. So plus now f of x times g prime of x. Now it's g of x's turn to have its derivative taken. That's exactly what we've done. Multiply it by whatever's left, so f of x and h of x. We did not take their derivatives this time. Plus, so we only have one function left whose derivative has not been taken, and that is h of x. So now we have f of x times g of x times h prime of x. There we go. We extended the idea. If we had four functions, say we had w of x, then, well, the first three terms would be multiplied by w of x, and then we'd have plus, and not continuing here. We'd have, we'd have these three terms, 1, 2, 3, and then we have plus f of x, g of x, h of x, and then w prime of x. So just saying, you will have to do, you got to know this. This is like, you got to extend this idea to more than just the, two functions being multiplied together. And, on tests and exams, assignments, quizzes, you will see this and you will have to do this. So you got to be able to extend this idea and understand, taking the derivative of each function and giving its own unique term. So as we see here, we took the derivative of one of the functions and then we multiply it by the remaining functions. That's one term, right? Then we move on to the next term. So that's, we take the derivative of another function whose derivative we have not taken yet. And, it gets its own unique term and its own unique turn. So that's a good way to remember it. So, well, seeing all these letters, seeing all these, f of x, g of x, all this, it's very confusing. You read in textbooks, they give it to you like this. There's a simpler way. And, textbooks do this, professors will do this as well, because it cleans up this entire mess that we're seeing right now. And, well, it's a very good way. And you really, you should not blow it off as just something extra, because you'll be doing a lot more of this and you're going to need it when you get into the quotient rule and when you get into, integration and the chain rule. You're going to want to get comfortable with this idea. And that idea is parameterization. So let's write our product rule out. Actually, first I'm going to explain what is a parameter. Well, in its simplest form, a parameter is just assigning a letter to something. So I'm just going to make it real simple and use very informal language. It's just assigning a letter to something. So let's write down our product rule. So let's say we want to take the derivative of f of x times g of x. Well, what did this come out to? Well, I'm just going to use the prime notation. This was f prime of x times g of x plus f of x times g prime of x. You can kind of see how this prime is moving, left to right in each term, right? So that's just a way to, visualize it and think about it. So, well, we can parameterize this. Looking at these two original functions. Well, the famous or most used parameterization is saying that u is one of the functions. So we're going to say one of the functions is u, and we're going to pick f of x. So we're going to say u is equal to f of x. Just this letter u, this parameter, u is equal to f of x. and v is equal to g of x. It could have been the other way around. It doesn't matter. Just as long as our work is consistent, it doesn't matter. We could have had A and B, but U and V are the most commonly seen ones. And I'm going to be working with those in my videos. So, get comfortable with this. So what did I say very informally? That a parameter is just assigning a letter to the functions, a function in this case. So you can see that, just writing U and V is much neater than, F bracket X bracket, and it cleans things up, you'll see. So what about the derivative of f of x? Well, how do we write that using parameters? Well, we could say u prime, obviously, right, is equal to f prime of x. We took the derivative. So same thing with g of x. Well, g prime of x, well, it's v prime. V prime is equal to g prime of x, right? We just took the derivative. And we just, we're putting that prime notation there because we're using prime notation. So, well, these right here, we can substitute these into this and transform this into a much simpler form. And what would that be? Well, let's do that step by step. F prime of x. What is f prime of x? Looking at this list, what's f prime of x? Well, f prime of x is u prime, right? So we got u prime times g of x. Well, what's g of x? Well, g of x, looking at this list, is just v plus, what's f of x? Well, f of x is just u, right? Looking at the list, times g prime of x. What's g prime of x? Well, it's just v prime, right? Looking at the list, it's just v prime. Now we got a form that is much, much easier to work with. Much more concise. And you'll be seeing a lot more parameterization when we get into, the quotient rule, the chain rule, especially in integration and calculus 3 and up. You'll see a lot of parameterization, so you got to get comfortable with it because it's going to come up a lot, and this is usually where you should start, getting used to it. So as we see, there's a lot of advantages of having this parameterization. It makes your work neater, more concise, easier to remember, because try reading this out. Try reading this parameterization out. U prime v plus uv prime. It's got a ring to it. U prime v plus uv prime. It's an easy way to remember the product rule. You just say it in your head. It's got a chime to it. Or you could switch, v prime and u at the second term, and you could say u prime v plus v prime u. It's just a good way to, keep it in your head. It's more concise than saying f prime of x times g prime of x plus f of x times g prime x. That's much harder to remember. This parameterization has a lot of benefits. And say we had a third term. Let's say we had a product of three functions. Well, we could say then, we could have this third function h of x, and we could just assign another parameter. We could just say w is equal to h of x, and we could say w prime is h prime of x, and we could just substitute that in because we know how to extend the product rule from our last slide to more than two functions being multiplied together. So the product of 3, 4, 5, 6, 7 functions, we know how to extend that, and we just add a parameter for each function. So, well, I've been going over the product rule for a bit of time now, so let's do some actual examples. Let's actually apply the product rule, apply what we've learned. So our first example says we have a function, we got y is equal to x sine x, and we're asked to find y prime. So for this example, I'm going to use both the parameterization and f of x and g of x. Later I'm just going to drop the f of x and g of x. I'm just going to stick with the parameterization because you should be working with the parameterization. And it's just the parameterization is just replacing, you know, f of x, g of x, and just all that writing with just one letter. You know, it's just much more concise, and you got to get used to that in calculus because you're going to be seeing that a lot. So let's continue. So, well, how do we do this? Well, let's say u is equal to f of x, like we had before. It could have been g of x, it's arbitrary. And let's pick one of these functions. Let's say x. This is equal to x. Because we got the product of two functions here, right? We got x times sine x. So let's say v is equal to g of x, and that is equal to sine x. So, well, what's the derivative? Let's write down our product rule. So let's write it down in terms of both the parameterization and the other notation. So our product rule is what? F prime of x times g of x plus g prime of x times, actually I'm going to write f of x first. F prime of x times g prime of x. And our parameterization, well, u prime is equal to f prime of x. V prime is equal to g prime of x. So let's just replace, you know, substitute everything. So what do we get? Well, this is also equal to, what's f prime of x? Well, f prime of x is u prime. What's g of x? Well, g of x is v plus, what's f of x? Well, f of x is just u. What's g prime of x? Well, it's just v prime. It's just v prime. So there we go. There we go. We got a parameterization and we got the other form too. So, well, let's actually take the derivative. So, well, what is f prime of x? You know, let's take the derivative. Well, what is f of x? Well, f of x is just x. So what's its derivative? What's f prime of x? Well, it's just 1, right? Using the power rule, it's just 1. So, well, what is the derivative of g of x? What's g prime of x? Well, g prime of x, well, g of x is equal to sine x. Well, g prime of x is equal to cosine x. So there we go. We got all our components. We got u prime, which is equal to f prime of x, which is equal to 1. Therefore, u prime is equal to 1 as well. V prime is equal to g prime of x is equal to cosine x. So it's all equal. So let's just substitute all these in. So what's the derivative? Well, what's u prime? Well, u prime is f prime of x. And what's that? It's just 1 times g of x. And g of x is also equal to v. So let's substitute that in. What is that? Well, that's just sine x plus, what's u? Well, u is just x. You know, f of x is equal to u, and that is equal to x. What's v prime? Well, v prime is g prime of x, and that is cosine x. Done. We found the derivative. We found y prime. Okay, so that wasn't too bad. So like I said, you know, you're going to take the derivative of each function, multiply it by the rest of the functions, then you're going to add, and then you got a new term, and you get a derivative of a different function that you haven't taken the derivative of already, and multiply it by the remaining functions, right? So let's go into our next example. So example 2, well, this is a little different. So we have some function, we got y is equal to x plus x e to the x. Well, and we want to find y prime. Well, we've got to use our sum rule here. We've got two terms here, right? So let's take the derivative of our first term. Well, the derivative of our first term, what's the derivative of x? Well, it's just 1 plus the derivative of the second term. Now, what do we notice about the second term? You know, what do we notice? Well, this is a product of two functions. So to take its derivative, we must use the product rule, right? We're taking the derivative of each term, And our second term happens to be a product of two functions. Therefore, we have to use the product rule. So let's do that. Let's find this separately. So we want to find this. So I'm going to say, arbitrarily, I'm going to say u is equal to x. And I'm going to say v is equal to e to the x, right? Instead of f of x and g of x, we just said u is equal to x, v is equal to e to the x. Not different. You just got to imagine, u is just f of x. U is just a function, just a parameter right here, right? We just assigned a parameter to each of these functions. So, just quickly visualize that in your head. Just get that in your head. So what's u prime? Well, u prime is just the derivatives with respect to x here. So what's the derivative of x with respect to x? Well, it's just 1. What's v prime? Well, the derivative of e to the x is just itself. It's just e to the x. Therefore, what was our product rule? What was our product rule? Actually, I already wrote that there. So, well, it said u prime v plus v prime u. So let's just let's just put the pieces of the puzzle together. That's it. We've already done all the hard work. We found the derivatives here. And we already wrote down our product rule. So we're just putting the pieces of the puzzle together. Let's do that. So what's u prime? U prime is just 1. What's v? Well, v is just e to the x. Plus, well, what's v prime? Well, v prime is just e to the x. And what's u? Well, u is just x. There we go. So we found the derivative of our second term. So now we're not done yet because we have to put everything together and we have to find y prime. So all we did right now was that we found the derivative of our second term. So let's put it all together. So our derivative of our first term, x, was just 1. So 1 plus e to the x, right? Because we got this, plus x e to the x, this part. There we go. That's our answer. So it's a matter of recognizing when to use the product rule. And when, just a matter of recognizing what rule to use and where we use it. And you got to get good at that because when we start introducing more rules, such as the chain rule and the quotient rule, you got to get good at recognizing when you have to use each rule. Where does it apply? And here we notice we got a product of functions and we notice that, this is where we use the product rule. So let's move on to our next example. So our next example is a little more complicated. So it says we have y is equal to 2x, x squared plus 6x. And we want to find, obviously, y prime. So what do? Well, we know y prime. Again, using our notation, write down the product rule. There's usually the first thing you should do is write down the product rule. If you're given, a product, 2 functions, write it down. 2 or more functions, write it down. So let's write it down. U prime v plus uv prime. I know in my last question I did v prime u. Doesn't matter, right? 2 times 3 is equal to 3 times 2. So doesn't matter for the order. So there we go. We got y prime is equal to u prime v plus v prime u, or uv prime in this case. So, let's assign our parameters. So let's say u is equal to 2x. You usually want to be u to be the first one. I don't know. It's just natural that way, I suppose. And v is equal to x squared plus 6x. Because we have a product of 2 functions. We got 2x times, in brackets here, x squared plus 6x. So there we go. We got u is equal to 2x, v is equal to x squared plus 6x. So what's u prime? Well, taking the derivative with respect to x, well, u prime is just 2. What is v prime? Well, v prime, take the derivative of this with respect to x. Well, it's 2x plus 6. There we go. We're done. Now we just got to put everything together. So let's put it all together. Well, what's u prime? It's our first term, right? Well, what's u prime? Well, it's just 2. So 2. Well, what's v? Well, v is just x squared plus 6x plus, well, okay, so what's u? Just u, not u prime, just u. Well, it's just 2x. And what is v prime? Well, v prime is just 2x plus 6. There we go, we're done. We don't really have to simplify it or anything. When you're on a test quiz, professors won't ask you to simplify because you only have a certain, obviously a short amount of time, and, they just care that you know how to take the derivative. They don't really care about simplifying it. Simplifying is more for if, you're finding slopes of tangent lines and you got this like complicated function, so you just want to, simplify it a bit. So it's easier to, plug in numbers and find a slope. So, well, let's find the second derivative. We've got our first derivative here. Let's find the second derivative. So I'm just going to erase all of this. Let's find y double prime. Y double prime. Let's just find that. Well, looking at our first term, this one. Well, we can just distribute the 2 in, and we can just use the power rule, on each term. And we get 4x plus 12. You can just work that out. So you multiply the 2 in and then just take the derivative. We could have also used the product rule. We could have treated 2 as, obviously a constant function, but its derivative would just be 0. So one of the terms in the product rule would just collapse to 0. And it's a bit of an overkill in that case then. So it's easier to just distribute it and use the power rule. But noticing our second function, we could distribute in and use the power rule. That's one way. But we're going to use the product rule because we're working with the product rule here. So we're going to use the product rule. So recognizing that this is the product of two functions, well, we're going to use the product rule. So let's do that. Let's do that. So sometimes you can use either rule. I'm just using it. Sometimes it's just one rule is overkill compared to the other. Maybe I am doing overkill right here, but I'm just demonstrating the product rule to you guys. So let's do that. So we have this, and we want to find its derivative. So we got that, and 2x times 2x plus 6. Well, let's say u is equal to 2x. And I know this is sloppy notation because we already used u once when we were finding y prime. So you know what I'm going to do? I'm going to call this u2, just to put this little subscript, just to keep our, keep our work consistent. So I'm going to put this subscript down. And I'm going to call v2, same thing for v. I'm going to put that subscript down because I've already used v. So I'm going to say this is 2x plus 6. And, well, let's take the derivative. Well, what's the derivative? What's u prime? Well, u prime is just 2. What's v prime? Well, v prime is 2 as well, right? So putting it all together, what do I get? Well, if I got the product rule saying, put that little subscript there. Putting that subscript there, so let's put it all together. Well, what is u2 prime? Well, forgot the 2's there, so make sure you put those there. If you want, you could just ignore it for now, and if you're still struggling to understand it. But all I'm doing is I'm just I don't want to reuse u and say u is equal to something else now, because that can be confusing since we already used u alone in the first derivative. So we just want to differentiate between the u's, the parameters. So we want to recycle the parameters, but we want to not make inconsistencies and have sloppy work. So let's continue. What's u2 prime? Well, u2 prime is just 2. What is v2? Well, v2 is just 2x plus 6 plus, well, what's v2 prime? Well, v2 prime is just 2. And what is u2? Well, u2 is just 2x. So there we go. We found the derivative of this second term. So let's put it all together here. Oh, not that. Plus, so we took the derivative of the second term. And what we're going to do now is we're just going to put it all together. So we've got 2 times 2x plus 2x plus 6 plus 2 times 2x. There we go. We're done. You don't have to simplify it. It's good enough. So there we go. So, well, what now? Well, let's move on to another example. Our last example, I suppose. So this example, it says y is equal to 3x times e to the x times cosine x. What do we notice? Well, we just noticed that we got the product of 3 functions. We can look at it as like that. Or we could say with a product of 4 functions, we could treat this as a constant function on its own. And, but knowing that the derivative of a constant is 0, we know that one term already just collapses down to 0. So we're going to treat this as, 3 functions here. And we already, we talked about extending the product rule to, 3, 4, 5 functions, multiple functions, being multiplied together. So here we have 3 functions being multiplied together. So let's extend the product rule. And you know what? We're going to use our parameters. So we're going to say u, arbitrarily. And I'm going to use f of x, g of x, and I think another one is to say h of x, because I want you guys to get this. So u is equal to f of x, and we're going to say that's equal to 3x. We just picked one. And we're going to say v is equal to g of x, and that's equal to e to the x. And we're going to say w is equal to h of x, which is equal to cosine x. There we go. We've done part of the work. So, writing down our product rule, writing it down in both ways, using both notations. Well, let's write it down. F prime of x times g of x times h of x plus f of x times g prime of x times h of x plus f of x times g of x times h prime of x. There we go. So now let's also write it down using our parameterization. So what do we get? Well, we get u prime times v times w plus u times v prime w plus u v w prime. As you can see again, much neater to write. So, well, let's fill in the gaps. Let's find the derivatives here. So, what's this going on? Okay. So, let's find them. Let's find u prime, which is f prime of x. Well, what's that? What's the derivative of 3x with respect to x? It's just 3, right? Using the power rule. Let's find v prime. Well, v prime is g prime of x, and that is, well, what's the derivative of e to the x with respect to x? We know it's just e to the x, it's just itself. And last one, what's w prime? What's h prime of x? Well, the derivative of cosine x is negative sine x. So, well, there we go. We did all the hard work. Now it's just a matter of just putting everything together, putting the pieces of the puzzle together. We know where they go. We know what they are. We just put them together. So let's do that. Well, our first term, u prime. Well, what's u prime? Well, u prime is just 3. What is v? Well, v is just e to the x. And what is w? Well, w is just cosine x. Plus, well, what is u? Well, u is just 3x. And what is v prime? Well, v prime is just e to the x. And what is w? Well, w is just cosine x plus our third term, write it down here because I don't have space, plus, well, what's u? Well, u is just 3x. What is v? Well, v is just e to the x. And what is w prime? Well, w prime is just negative sine x. I'm just going to put that in brackets, and you can move the negative sign and simplify it after. But there we go, we're done. Now, I had this important consideration, but I basically already talked about it, and it was just dealing with multiple functions. So we've already done that. We understand now that if we have 3, 4, 5 functions, we just keep extending the product rule. So say we had 4 functions, we would assign maybe we call it t of x, and we would give it a parameter z, and we just extend the product rule. So I'll do a math on the go video, and I'll do a tutorial. But I hope you guys enjoyed this video, so thanks for watching.